So welcome everyone, I guess we can start. Thanks very much for attending my talk and again for listening to me in English. You probably did read the abstract and you know what the talk is about, but I just want to start with a few disclaimers about the talk before even introducing myself. We did talk about continuous delivery and continuous deployment, and I've seen, hands showing and how many people are doing. So it seems like a lot of people have already cracked this problem. However, I want to show how we're doing it, and I'm more than happy to discuss with you later on how you guys are approaching it. Jenkins is not my favorite CI server. I'm just not the Jenkins lady, as they used to say in Sky. It's just what we use at the moment. So I want to show something in practice. And in terms of Kubernetes, I'm not going to go deep into all the details because this talk is short. Documentation is very good. I want to show a few practicalities. So if you're here for that, welcome. Hopefully you won't be bored. So I'm going to informally introduce myself. I am a principal software engineer at Sky, and you're probably wondering what is that principal thing. Most of people spell principal, which means just in theory, but it's actually one level above senior developer, but it doesn't mean you're better than your other senior developers. It just means you work very well with them. And if there is a good practice, you need to share it. You need to tell to the other teams. So we have a lot of teams in Sky, and we work in silos sometimes, so I get some time to break these silos. And also work with a few teams, coach them, like young graduates team, which is very rewarding. I'm a polyglot developer because I've done from PHP, Ruby, and now I'm very much into Python and Java. I pulled my sleeves up and done some DevOps work and work on Kubernetes and Jenkins. It doesn't really matter. I love technology. And even though I've been for 7 years in London, I am from Romania, actually from a city just south from Kiev, so this reminds me of home. It's awesome. Thank you guys for inviting me. So yeah, let's go into the actual content. I will try to be concise, and I want you to come and reach out and ask me any questions after. Basically, I'm going to start with what it means to build a smart deployment pipeline, and I'm calling it smart because it works very well for us. And then I'm going to show you our techniques to decouple from a target infrastructure. I think that those 2 points cover some 2 key elements to achieve continuous delivery. If you're not coupled to your infrastructure and your pipeline works for you, you're golden. And then I'm going to try and demonstrate how we put up an application out there and deploy it in Kubernetes using a brand new pipeline. So hopefully that will go well. And a few words about next steps. Without further ado, I'm going to start with the first thing that pretty much everyone started before, the problem. Because if you don't have a problem, then why are you trying to find a solution? So we ended up into a bit of a mess about a year ago. We are a corporate, so in Sky we get budgets, and we get in no time 6 teams, probably almost as many people as there are here, ready to pull their sleeves up and just work. And you have a bunch of requirements, and then your high-up manager comes and says, well, actually, you don't have a target infrastructure because we might deploy in AWS, or we might deploy in an in-house infrastructure, but you go and code, do your stuff, because then we'll figure it out, basically. So we had this problem. Then we had inherited the Python application, which we decided to use, and most of the expertise was Java. We have some Python expertise, so we have Python apps, Java apps, think about them, think about how to deploy different technology. And obviously, there were no DevOps or Ops resources available. So that, not at that point in time, but we had the money and we had the teams. So good luck running those teams in parallel. So we started thinking, how can we actually scale to give those people something useful to do and start just building software that actually works. We had the business requirements. We knew what we need to deliver. We are delivering a commerce platform. So basically, Sky has a lot of video-on-demand applications, and people can buy subscriptions. We knew exactly what we need to do, just didn't have anywhere to put it. So we said, fine, we need to take matters in our own hands and start thinking about how are we going to first even start about deploying this thing. So we said, we have so many teams in parallel. We have to do something about it. Imagine that you have a CI server. You find some nodes somewhere in AWS, because we still had access to some accounts. We spin up some servers, put up a CI server, but then imagine 60 people going and changing manually however they wanted their pipeline to be, whatever testing environments and so on. That would be a mess. So we said, how about we go about this differently? We say to all the teams, one small team took initiative and said, how about we define some standard pipelines? I mean, what do you have when you go to production? You have a production application that goes there and serves your customers. Then you might have a demo application which is used for purposes like demoing internally to your technical analysts or your business. I don't want that thing to go in production. I don't care. I'm building some REST services. I have mocks. Do they have to go in production? Hopefully not. So different kinds of pipelines. So we decided we're going to have 3-4 categories of pipelines. We had something for our libraries, for example, something simple, and we need to script those things once we decide what they are. We need to make them so that if you add a step, every team benefits from that step. And another challenge, if you have Python apps and Java apps, then good luck building a different pipeline for each of those. I mean, not each of those, because we had one Python app and about 5 Java apps. So to keep an application on a different pipeline, it doesn't really work. We are trying to achieve continuous delivery on a microservice platform. We have to have the same quality gates. All these apps talk to each other. If I don't know when the Python app is going to be in an integration environment, then how am I supposed to test against it? So we said we need to build something which is independent of technology. So we thought, and we didn't start with this. This is what our pipeline looks like now. But we said, okay, let's have 2 parts. First one, what happens from when I commit the code? What happens daily, let's say, when you commit your code? You commit your code, then you run your tests, you build your artifacts. We're using containers, so I'm going to get into that in a moment. And then you push to a test repositories. And from there, obviously, you parallelize to save time. You test non-functional testing, functional testing, integration, whatever you want to add there, it's going to be parallelized, but then you're deploying into a showcase environment. We are in an agile environment. We need to showcase regularly. We thought that makes sense. But after you've done that, for each commit, there is the second part. I did say that we do continuous delivery. We do achieve to do continuous deployment, but let's be realistic. Let's start with baby steps. We said, fine, we covered what happens from one commit to the showcase. Now we need to think about further how this code gets into production. So what we started to implement is deploying into a staging environment and 24 hours running load tests, simulating what people are doing in production exactly, so we catch every single error that might happen and alert on it. We are at the point of actually monitoring those alerts using Prometheus. And if your application is healthy, then you can go to production. But right now, we are not going to production automatically. We still have other checks in place, so you basically deploy to production manually. So that's how our pipeline looks like, and it changed so much. And for a production application, these are all the quality gates that anyone in the team needs to implement. How they implement it? That's actually their problem. So I'm going to get to that in a second because it might seem quite controversial. Just a quick note on the tools. I did say we're using Jenkins. We use it from a couple of reasons. First of all, we are used to it. All of us have used it before. It works well with our infrastructure and the way we deploy things. It's deployed in Kubernetes. It has all the plugins that we need. I know that there are great CI servers out there, and they do all kind of integration with Bitbucket and Jira, but we simply didn't need those. We needed something to script the jobs, like the DSL plugin. We needed images for Docker, and we needed a Kubernetes plugin, so we are able to take Jenkins and deploy it in Kubernetes and have slaves on demand. That's what Kubernetes plugin does. Basically, you have a master, and you have a bunch of slaves, and it spins up slaves on demand, you run your tests, and then it tears them down. You know, when you provide a target environment like Kubernetes, then it's able to discover the cluster and tear down the slaves. So that's what it's doing. So simply because Jenkins offers us what we need, that's why we use it. So moving on from tools, I want to basically tell you what were the building steps for us to be able to achieve with 60 people on the floor that didn't have stuff to do or infrastructure. What did we need to do in that scenario? So we needed three main things, building blocks or building steps, I call them. First of all, each application needs to instruct whatever constructs your pipeline, what kind of pipeline they want. You're an application. The concept is that you know whether you're going to go to production or not. You're a mock. Then I need to tell the pipeline generator, I'm a mock, and I need to be deployed only in the ephemeral stubbed environments, which is great. So apps take control of what kind of pipeline they want. And then the pipeline generator, because it's a standard pipeline and it's scripted, knows what to do with it. And I'm going to show you later in the demo how it actually fits in together. So you define what kind of pipeline you want, then you get the pipeline, but then you have freedom to implement the steps. And that's when I'm going back to my controversial point, like, why would the applications do whatever they want? Well, I'm not going to go in a team and tell Python experts how to test their functional or non-functional requirements. It's not the job of the pipeline. I'm the pipeline advocate. So I'm telling, you know what? I'm going to give you to implement this task, and it's up to you how you do it. Do you need a Python virtual environment? Do you need libraries? You know what you need to do. So that's how we manage to actually scale and empower each team to actually do something in useful time. So once you have these building steps, let's see how an application would tell the pipeline what it wants. This is a very simple YAML configuration. I have a service demo, and I have a service demo mock, and I'm telling to the pipeline, I want a pipeline of type production, and I want to monitor some namespaces, canary and production. You probably say, what the hell is canary anyway? Well, obviously, if you're doing continuous delivery, you might have heard of it, but I haven't mentioned it in my previous slides. I haven't because we're actually thinking of getting rid of it, because we're using Stage as a gateway for quality. Canary is supposed to be an environment that takes 10% of your traffic or whatever you decide and monitors constantly that you don't have errors. And once you don't have errors for 24, 48 hours, then you promote to production. We're thinking that Stage and load testing, it would be enough for us. So, but back to the original point, I'm just instructing the pipeline that I want a production pipeline and I want to monitor some namespaces. And that's it. Pipeline should do its job. And how is it doing it? Well, we're using DSL, domain scripting language. I'm sure that most of you are actually familiar. And we can we use groovy DSL. So this is a snippet of groovy DSL which run on Jenkins. It instructs it to add a job, pull from a repository, and have a Gradle task as a step. As simple as that. Obviously, we have a pipeline generator because your pipeline has to include specific steps, which if we go back, you have prod and mocks type of pipeline. So my pipeline needs to know how to use this DSL to create the entire pipeline, and that is custom. And it's something that could be open source, but it's a bit of work. But moving on from pipelines, not completely, because obviously as part of your pipeline, ideally you deploy stuff. The second point that I wanted to make for this talk is that, especially if you have a requirement like we did, decouple from target infrastructure, we don't know AWS or internal infrastructure, then you need to decouple your applications. If you sit in your IDE land, as I call it, if you sit in your IDE land and you start writing scripts that interact with all kinds of systems, and they're very specific to those kind of systems, then it's not going to work when you have that many people working with so many apps. It's just not ideal. So we said, let's decouple it up to a point. And that point is, we don't have DevOps, we don't have Ops, so we try to make ourselves, to make our way out there. So how do we go about it? Well, the logical steps seem to be, we use containers. And why? Well, obviously for us, we needed to have an entity that contains our application and all the libraries that we needed, and we wanted to push it on a node and don't depend on what sort of infrastructure that node has. I don't care about the kernel, and I can't care, because I'm trying to decouple, and I'm trying to get something for those teams to do. They need to understand what sort of libraries they need. Container, we will have Java and Python containers in our situations. If you don't know your dependencies, but you're trying to modify a server that everyone else is using and install God knows what, you're doing something wrong. So we were like, first thing, just containers come with their own downfalls, obviously, but let's try and understand our dependencies and deploy. But then once you have containers, then you can't just leave them out into the wild. So we said we need something to orchestrate them. Obviously, there are security constraints, there are service discovery constraints. We said we need to look for something that is out there. It's open source, because we encourage actually Sky contributing to open source community, something that has really good documentation and seems to give us all the features that we want. And also a big part of our systems is reliability. We can't just deploy and take the app down. We need to be up all the time. And we said we need something that is able to achieve that. So we went with Kubernetes because it has a sort of reconciliation loop concept. So basically, if you specify, I want on a specific node a pod, but actually my application has 2 pods. The concept of pod is basically an entity that can contain 1 or more containers. I could actually whack into it a Python and a Java container, but the basic kind of the baseline of Kubernetes and what they specify is don't put important application containers on the same pod. Because you basically, if you're doing that, your pod is replicated across nodes, right? So I have, for my Python app, I have a pod on node 1 and a pod on node 2. The whole thing is, if one of them goes down, you have, anyway, it's resilient, but if you whack 2 important containers that contain each other for memory, then if that pod goes down, it's pretty bad. You can have another replicated pod, but what if that goes down as well? It's not is much more higher chance that the memory contention would actually kill your pod, so keep your containers separated. So we kind of liked the idea of also having an API that we can interact with and basically scale up, scale down from the command line using kube control. So we went for Kubernetes. Not to say that there are not other technologies out there, but we contribute to it. We basically have a lot of fixes, and the community is pretty active, so we like it. We did choose it, as I said, because of the self-healing mechanism. Our deployment is continuous. We have to be up all the time. If it's self-healing and replicated, it's going to be up all the time, and hopefully. And that was good for us, and honestly, you don't want to design your own service discovery mechanism. So, yeah, we chose Kubernetes pretty much. I'm just going to, there is another very important part of what we've done for decoupling. I said that we use Python and Java applications, so we said we want to deploy in the same way all the applications, and we have to wrap everything in Gradle. We were using Gradle for Java applications, so we said, well, you can apply a thin layer of Gradle around your Python app and use the same deployment tasks. So as I will show in demo, if you have a Gradle simple plugin that does all the packaging, all the publishing for you, all the Kubernetes tasks that you need to use, then your application is not dependent on whatever Kubernetes is and whatever infrastructure you have. So we created our own Gradle plugin. That was the easiest part from the project, to have some Gradle tasks that deploy to Kubernetes. But we ended up with having just a bit of configuration in our projects that says deploy to X environment, which in my opinion is pretty powerful. So I'm going to make a short summary of this, and then we can go into demo and hopefully have more fun. What worked for us, as I said, were two things: pipeline being generated automatically. Agree on what pipeline you have. Don't do manual changes on CI. That just doesn't work. If we do manual changes on CI at the moment, they get overridden with the next deployment. So it's your own responsibility if you do that. And I think that worked very well for us. Also, give the apps the responsibility to implement NFT tests, functional tests, everything. Don't script in your CI server anything related to that, about how you want to run your test. Your app should encapsulate that into a single task and nothing more. Then, when you generate the pipeline and you have all the steps in place, don't start and build scripts for deploying to your infrastructure. Put that into a separate plugin that is reusable for all your projects. Basically isolate up to a specific point. You still need to have a configuration. And what that gives us was new applications that are easy to bootstrap. And hopefully you will agree with me after the demo. Nothing is very easy or simple, but once you've done the hard bit and you don't repeat the hard bit every time when you spin a new app, which we do often, then it's pretty easy, and I think that's the payoff. So once you decouple from the infrastructure and have a generated pipeline, I think you're pretty good. So I'm just gonna cheat, and because for my demo I need to connect to internal Kubernetes clusters, and this is over VPN in Sky, I thought I'm not gonna risk myself over Wi-Fi, so I've done the demo at home a few times and have a screencasted version of this, which probably we can rewind or we can pause if we need to. So I have it recording. To be honest, it's actually harder to record than do a live demo. So before I start this, I hope you can see, because there is quite a bit of light, there would be more browser screens, etc., which probably you'll see better. What I want to kind of deliver as part of this talk, really, is that if you have an application, it's easy to bootstrap, and you don't do manual changes on CI, then that's a real win in achieving continuous delivery. That worked for us. Independent of what CI server you use, I think there are some practices which you can take away, hopefully. So I'm going to start the demo, and you're going to see me actually doing some stuff in real time. We have a Gradle project, basically, which is called CD Pipeline Demo. This is played really slow, just for the purposes of me explaining. I wouldn't type that slow, usually. This project includes a sub-module, which is Gradle. All I'm using here is an Axiom release plugin for versioning, and I'm applying it for all my sub-projects. So the project that I want to deploy, it's a service demo. K8 plugin is our Gradle plugin that does all the publishing and etc. So I'm applying that plugin. I have, for the purposes of demonstration, I have a Python app. That's my Docker file. You've probably seen a Docker talk earlier today. I have some dependencies. And I have nothing in my Jenkins, just bootstrap pipelines. So now I'm going to instruct the pipeline, give me a sort of production-like pipeline. That's what I'm doing. This is what I would do if I would start a new app in my company. I actually cut the time when I'm waiting for the build, because it's quite slow. So I have a service demo, and I'm instructing the pipeline to be of type production. So assuming that I push that code, Bootstrap Pipelines is actually a job that only gets information about the repositories, and then it starts on building your pipeline. So you can see that it added a folder for me, and it triggered building my project. Building my project should create all the jobs that I need. And that's where we use DSL. So just to pause here for a second, I haven't shown the code for Bootstrap job, because that's our internal pipeline generator, and it's using DSL. But basically, I'm not adding any server configuration at all as part of this. Once I said this is a pipeline of type prod, and I build that job, it builds me all those jobs. A monitoring as well, because I said monitoring. And then we can introspect on the service demo and see what sort of jobs are there. Obviously, I'm going quite slow, just so I can explain. So these are all the jobs that are created. You can see that I still have canary at the end there, because we haven't removed it yet. So my pipeline, after I commit, is building, is testing in parallel, it's pushing to a release candidate, and then it's deploying to a showcase. That's what happens every time when you commit. And obviously, you have the daily jobs, the staging, the canary, which we're planning to remove, and then the production job. So that's our entire pipeline, how we get to production. We've been in production since 1st of November for tech trials. Hopefully nothing will happen wrong. So here, I'm just exploring what do we configure as part of a job. I did say that all the power is in the application. The application should implement the appropriate steps. So here, I'm just showing what we configure the Jenkins jobs like. I only have one Gradle task, and I say, implement CI functional test. That's all that your app would do. So I have some release tasks, because I use that Axiom plugin and the Gradle help tasks, nothing else. So I want to show you what happens when we apply the platform plugin. Platform plugin, just a reminder, it's the K8 plugin in this scenario, and it's custom, and we use it to deploy stuff to Kubernetes. So you can see I don't have any deployment tasks. So let's see what happens after we apply the plugin. Okay, we have some promotion tasks and some build tasks. Cool. So that's what the plugin gives us. So I'm not putting any logic into my app about deployment. I have some local Python image, which I now want to build. I pulled it already for this demo because it takes forever. It's quite big. So now I'm using the task generated by the plugin to build my image. Okay, so now I build the image that I want to deploy by using the build image plugin. Checking the images. I think very quickly here you can just notice that I have a new image tagged with the new version. We basically use the custom plugin to leverage the fact that my project has a version and tag it with that. Because once you push it on a repository, which I'm not doing part of this demo, because it's really slow, and I've done this demo 5 times, so the image is already there. Once you push your image, you want to know which image to deploy, obviously. So that's what the task is doing. Okay, checking the current version, it's 010. So that's the image that I want to deploy to production. And let's explore what this plugin gives me. I didn't instruct it yet where to deploy. So I did mention that you can decouple your infrastructure, but only up to a specific point. That point is the configuration. So what I'm doing here, I'm saying push to zero-score test. Zero-score is one of our teams. So you can see I have some promotion tasks, but now I'm actually configuring the plugin to tell it which Docker repo to push to. I don't have if we pause here for a second, you can see the pattern. I don't have in my application any URL or any information about what cluster I deploy or what Docker repo I deploy. My plugin has some keys where I say, I want you to deploy to test repo or to release candidate repo. I'm instructing the plugin that I want that, and it encapsulates the logic. So it gave me the push image to test. Let's see what else we can do with the plugin. Again, I'm happy to discuss if anyone is interested in this approach, but the plugin is actually quite easy to develop. So I want to deploy my application to a functional environment. So I'm telling the plugin, you know what, a namespace in Kubernetes, I want you to call it service demo functional, assuming that you've created that namespace. I want you to pull the image from the test repository. And let's see what else. I can also instruct it how many replicas I want. And kube control context is, if you have 3 clusters, a dev, a tools, and a prod, your context would be dev, tools, prod, for example, as we have it. So I want 1 replica in the dev cluster. So let's see what are the tasks available after I configure the plugin. I should have some deployment tasks. It's very predictable for me. I'm sure it's going to happen. Deploy to service demo functional. So this is the point where my plugin, I just paused it for a second. My plugin knows already to deploy it. I tell it which namespace, which cluster, how many replicas I want. So it should know how to deploy now. So let's try and use that task. I'm just double checking. I think that everything is fine. The name, service demo functional, kind of corresponds to the name of the task. So everything is built in flight. So I'm going to try and run the task, and also using kube control to explore the Kubernetes cluster. we're gonna try and see what happens if my pod is actually gonna start running or not. So namespace is where you basically group your pods for memory contention. You can give the namespace a limit, and you can deploy a few pods in it, and also get service discovery. So I'm trying to build here, but I'm getting an error because it says you don't have a pod configuration. So my application wants to deploy itself to the cloud, but doesn't have any configuration. So I'm adding a pod configuration. When I was explaining earlier about the Kubernetes pods, I was basically saying that they have a specification in terms of memory and requests. We can actually speed a bit through this. Okay, it's going a bit faster now. You can give it an image that it tries to pull from. So basically, that placeholder, our plugin replaces that image with your current version, and then I'm giving it a limit in terms of memory and CPU. If you used Kubernetes before, then you know that, just to pause here for a second, requests basically tells you how much you need to allocate on the node before you deploy, and limits, it's actually a hard limit. You can't use more memory or CPU more than that. But let's try and deploy. I'm gonna watch what's happening in this namespace, just so you understand when the pod is created, and hopefully it will be deployed. Okay, so let's try and deploy again using the task. It's actually connecting to the cluster and trying to create a pod in the namespace. Okay, so here we go. We have a container creating in that namespace. So you basically, I think now the demo just shows the fact that when you want to implement a functional test step, for example, you go in and obviously you have to deploy to the test environment first. So you're going to deploy to the test environment, and you're going to have the task already available. So I think this is the wrap-up of my demo, and I know that it's been a bit fast, and it's quite a lot to look through all the files and everything that I was doing, but I think that the takeaway is try not to embed anything that has to do with the pipeline or the cluster in your code. This is my Gradle file. I'm applying some plugin, and I'm doing some configuration, and I'm actually doing something really powerful. I'm able to deploy to one of the environments. So once you repeat this step 5 times, that image that I had about the pipeline, actually, you probably are able to do that in half a day if you go and repeat through all the test environments, because that's what those tasks do. They deploy, and then you run your integration tests. Obviously, you have to implement some tests. Hopefully, that's clear. So that was my demo. I want to wrap up with a few future improvements, because this is where you come in. Maybe you can help us. Basically, we want to, if anyone is interested, we want to open source the DSL jobs generator. So that could be a motivator for us. We want to look into Jenkins 2 point something. If anyone has used it, then it might be useful. I think it has embedded DSL, which we might not use, but it would be good to hear opinions. We have automated deployment of slaves, Jenkins slaves, and we have them on demand. So every time I want to add a new requirement in my slaves, it gets rolled out automatically. But we're looking to do the same thing for the Jenkins master. So those are our milestones. And I have, obviously, even though we use some custom plugins, which I'm always not keen to talk on conferences because people want to see code. Those are minimal, and actually we have used a lot of open source GitHub repositories which we contribute to, the Kubernetes ones and obviously the Jenkins plugins. Yeah, so that's me.